All right, guys, you should have your protein synthesis worksheet assignment opened in Cami. So you should have a worksheet that looks like this. You should also have your codon chart opened in Schoology. So I have a little tab here. What I did was I opened my codon chart in Schoology. I reduced it to 75%. And then I have this codon the codon chart on a different tab than my Cami worksheet. And then I just kind of have it centered over into my screen. So we're going to reference that later here, but I want to make sure you have that. So that is set up. I'm going to click back here on my Cami tab. Again, I have that by itself, so we can work through this. So today's worksheet is going through protein synthesis and how it gets transcribed or like rewritten from DNA into that messenger RNA, which carries a specific code, and then how that messenger RNA is then read or translated by the transfer RNA, which then carries specific amino acids, and we're going to work through identifying what those amino acids are. So for our worksheet, at the top, you're going to see DNA and RNA and the base combination. So for DNA, the bases T and A always match up together, and then the bases C and G always match up together. So in your examples here for number 1, number 7, number 11, and number 21, those are your DNA strands, and I've already completed those bases for you. So you have a complete strand of DNA here ready to go. And what we're going to practice doing is transcribing that or rewriting it into that mRNA. Now, with RNA, if you remember, the bases change a little bit. So when we read from the DNA strand and create the RNA strand, if there's a T in the DNA, it's going to translate to an A for RNA. But then if there's an A in the DNA, it's going to change to a U for RNA. And then the C and the G's stay the same. So we are going to work through this first section together, and then we're going to answer some of the questions, and then I'm going to give you guys time. You're going to practice. You can always rewatch this video of how we do this for this first section, questions 1 through 4, and you can always email me. So let's begin. Again, your DNA strand is already created. So we are now going to transcribe our DNA into RNA. So I'm going to use the text box, and I changed my color to blue just so I can kind of see the difference. If you click to like the left side of the circles, it'll usually line your text box up pretty well. So I'm going to capitalize my letters as well just to see them a little bit better. But I'm looking at this DNA strand. I'm going to do this. So I'm looking at this DNA strand here, okay? And I am matching it to this RNA strand. So if it's a T in DNA, it's going to stay an A for RNA. That's pretty simple. We just put an A there. Now, we have an A in the DNA. So now, because there's an A, in RNA, the A changes to a U. Instead of putting a T there, we're going to put a U. And then our C always will be a G. The C and G go together. So then we have another C. That will be a G because we're doing the opposite bases. But then I have another A. So that A is going to become a U. And then I have another T. That T will stay the A, since that's the opposite base, and we'll continue to go through. Okay, so I'm going to continue to fill this out, remembering that our bases are opposite. There's another A, so I'm going to make it a U. There's another T, so that just becomes the A. And we'll continue on. So the last two letters should be U's to match up with those A's. So now you've created your mRNA strand. So as you can see, those A's, instead of turning into T's here like they would have in DNA, we now make them U's for the RNA. So now with the translation step, I'm going to change my color here. With our translation step, this becomes a little bit easier because you're taking the mRNA and you're just translating it into the opposite bases, still using the RNA bases. So you don't have to worry about any T's, it's all A, U, G, or C. So for A, we match it up here and it's going to be U. Okay, so then for the U, that opposite base is going to be A, and then G and C are still the same. So this G is going to be C, and so on. So we'll continue to create those bases, just matching it up with what those RNA bases would be. Continue to go through that. And if you need a reminder, you can always scroll back up to the top of your page and look at those references just to make sure you're using the right base. So you can always scroll back up to the top here and double check. So now we've looked at our DNA, we've transcribed it into our messenger RNA, and we've set up the bases for the transfer RNA. What we're going to do now is use our codon chart. So so we're using our codon chart. That's really bad. Sorry, I can't draw with my pen. Okay, so these are our codon charts. So what we're going to do, if you notice, these bases are in threes. Okay, so it has 3 pairs for 1 amino acid, or 3 bases for 1 amino acid. I apologize. So what we're going to do, we're going to look at what those bases are, so U, A, and C, and we're going to determine the amino acid. So we're going to scooch our page over here so that we can now see our chart. Okay, so how this is going to work. There is a column, if you look at your codon chart, that says first base here on the left, and it has U, C, A, and G. Then at the top, it has second base, so that middle base, and again, U, C, A, and D. And then the last base, so that third base, is on the right side, and it has them all broken down. So how this works, you can either look at this chart, and as you can see, the UAC, you can just try to find the UAC based on where those 3 bases are. You can kind of see them there, or you can follow this. You're going to look at the first base, so I have the U. Now I'm going to go across that row until I find my A base, And where that column and that row intersect is where I'm now going to look for that third base C. So then I look for UAC, and as you can see, it's right there, and it belongs to the amino acid tyrosine. Now, we can just abbreviate tyrosine as TYR. So what we're going to do is we're going to go back to our chart here, and we're going to type in TYR. That is what our amino acid is for that first base. So then if we go over to our second one, we have CAU. So again, we're going to start at that first base. We're going to go to the letter C. Then we're going to go across the table to A. And where that row and that column intersect is where we're going to look. And then we're looking for the third base U. So we're looking for CAU, and it's at the top there. And it belongs to the amino acid histidine. So that is abbreviated HIS. So we're going to type that in. Then we move on to our third one, and we have CGA. So again, we're going to start at this first base column and go to C. Then we go all the way over to the right until we get to the G. And then we're looking for A, CGA. Now this one is a simple one because the amino acid arginine can be coded with all four of those different codes. So arginine is just abbreviated ARG. So we're going to click that in here, type in our ARG. Now we're going to continue to move on to our last two bases. We have UUG. So again, looking at our first base U, go over to the second base U, and then we look for the letter G. That belongs to the amino acid leucine, which we abbreviate LEU. And then our last amino acid is GAA. So looking at our first base on the codon chart, we go all the way down to the bottom G, and then we go over to the A in the second base column here, and then we look for another A. So GAA belongs to the amino acid glutamic acid, and we just abbreviate that GLU. So now I'm going to open my CAMI document here again. You can see it all. We have just completed protein synthesis for this example. We've taken our DNA, we've transcribed it into messenger RNA, and then through translation, we've determined what that messenger RNA code is, and we have identified the amino acids that can build that protein. So now what I want to do, you guys have this example. You're going to work through completing the next examples. So you have 7, 8, 9, and 10. Then if you scroll down, there is a second part. I've written the bases at the top as a reminder, but you're going to complete 11, 12, 13, and 14, and then 21 through 24 if you have it. I did want to go over these notes, though, quick, that you have to circle. We will probably use this worksheet as a reference, so it's important that you have these notes circled as well. So, let's begin. mRNA is synthesized in transcription. So that just means this is where we are creating that mRNA strand. Synthesized means like created or copied, duplicated. Then mRNA has what we call codons. So those bases are all called codons that are red. Or if you need to think of it, think of mRNA carrying the code, which is red on the codon. Then we're going to skip over our numbers here a little bit, and we're going to jump down to 15. So you have these notes filled out. There are 3 codons that equal 1 amino acid. So those three bases that we read are what equals that one amino acid. Then transfer RNA, if you remember from yesterday, brings amino acids to the ribosome because the ribosome is where protein synthesis is happening. Then I already had 17 completed for you. A polypeptide is a sequence of proteins. So a polypeptide is like a long chain of proteins which are made from amino acids. Then, if you remember back from question 6 on this page, messenger RNA has codons, which means that transfer RNA is going to have anticodons. Then, transfer RNA transfers amino acids during the translation process, where it's reading that message and putting the amino acid in. And then ribosomes are where translation takes place, so where that message can be decoded. All right, so once more, you guys are going to continue working through the rest of these 3 examples using that codon chart. Please go back and forth with this video if you need reminders of how to fill it out, and look at this example as well. Once you are done, please make sure you submit this back into Schoology. And if you have any questions, please email me. Have a good day.